Oh yeah, in this video we're going to go over how to simplify simpler rational expressions, and I'm going to show you how it relates to simplifying fractions with just numbers. So let's look at that first, and then I'll show you how you really already have the tools needed to simplify rational expressions. So the instructions are simplify, then list the excluded values. So we'll go over that shortly. First thing I want to go over is how we simplify fractions. Now at this point you might already look at this and say, well, that's 2/3. But what's really going on here is we're dividing the numerator and denominator by the greatest common factor, right? The highest factor that goes into the numerator and denominator. And this is no different in what we're going to be doing with the algebra. But I like to rewrite this, just when I'm going over all this, as the product of the greatest common factor and the other factor that's involved. So the greatest common factor is 4, so 8 becomes 4 times 2. 12, the greatest common factor, again, between 8 and 12 is 4 times 3. And so now we have something where technically the 4's divide out. They each equal 1. And you're left with 1 times 2 equals 1, or over 1 times 3, which is 2 over 3. So remember that what we're doing here is we're dividing out common factors. And when we divide out common factors, we get 1. Okay, so keep that in mind. So I'm going to erase all that, but that's the main idea just now with variables. There it goes, getting erased. Okay, here we go. So now we're going to go old school. 8x cubed over 20x to the 5th. So again, we're going to look at this. I'm going to go old school here, divide down by the greatest common factor, but the first thing I'm going to do is list excluded values, or what are called restrictions. I do that first before I divide anything out. So I factor, and then before I divide anything out, I list any values that will make the denominator 0, any x values that make the denominator 0. And to see why I need to do this, check out my earlier video just in introducing what rational expressions are. So 8x cubed over 20x to the 5th, if I divide 8 and 20 and just treat that as a separate fraction, 8 goes into 20, well, 4 goes into 8 2 times. So what I'm doing there is doing 8 divided by 4, and 20 divided by 4 is 5. And now I use my exponent rule. So this is old school exponent. So if you're like, wow, I'm having trouble following this, check out in my Algebra 1 class or even pre-algebra classes my videos on how to divide and use exponent rules with that. I have plenty of problems like this. Okay, so when you divide with the same power, you subtract, the same base, you subtract powers. So 3 minus 5 is x to the negative 2, which leaves us with 2 x's in the denominator. So it's simplified. Now, one thing to notice are my restrictions. What would make the denominator 0? Well, if x were to equal 0, that would make the denominator 0. So this expression simplifies down to this, but x can't ever be equal to 0. Very important. Okay, on to the next problem. Now we're going to get into some of the new school methods. What you should always look out for in any problem, the first thing you do when you factor is look out for the GCF, the greatest common factor. So let's look at the greatest common factor in 4x minus 6. 2 goes into both of those terms, no variables, so that's going to be 2 times 2x minus 3. And to see how to factor out a greatest common factor, watch earlier videos in either my Algebra 1, well, it's going to be my Algebra 1 class, how to factor out greatest common factors. It's a great video montage of how to do it. All right, now I'm going to assume that you know how to do that. So 2 times 2x is 4x, 2 times negative 3 is minus 6x, so that's correct. And then we're going to factor out the GCF in the bottom, which is 5. So we get 5 times 2x minus 3. 5 times 3 is minus 15. 5 times 2, yep, so we're good. So now, before we cancel things out here, I want you to notice that these factors, 2x minus 3 and 2x minus 3, are the same numbers. However, if we just divide them out, we'll have no more x values, and you might forget that there's excluded values. Remember, the denominator cannot equal 0. So before I divide anything out, I do a little bit of work, and I set the denominator part with the x value equal to 0, because that's what I don't want. I add 3 to both sides, that gives me 3, and I divide both sides by 2. X is equal to 3/2. So that's what x can't equal, because that's what will make the denominator 0. Okay, so x cannot equal to 3 over 2. Now, what we notice here is this is just like the 8 over 12 example I started the video with, where the 4's divide out. These are the same exact number. You're not dividing out 2x and 2x, to be very clear. You're dividing out everything. 2x minus 3 divided by 2x minus 3, the whole number that is. That divided by that will give you 1, right? These divide out to give you 1, and you're left with the fraction remaining of 2/5. So you have 2/5, but x cannot equal 3/2. So what does that mean? That means that this expression here is going to give you a number of 2/5. For any x value you plug in here, you'll get 2/5 out, except if you plug in 3/2, then we have an issue. That's it. All right, let's do a couple more just to practice them. So let's look at our greatest common factor in the numerator and denominator again here. So the GCF in the numerator is going to be 8x. That's the highest number that goes into both of those terms. So that leaves me with an x here and a plus 2. And if I distribute back in, I'll see that it checks out all over. My greatest common factor in the denominator is 5x squared. Interesting. Let's see what we're left with. Well, x times 5x squared gives me 5x cubed plus 2, because 2 times 5x squared gives me 10x squared. Nice. Okay, before I go and divide things out and reduce everything down, let's figure out our excluded values. So let's do this mentally. What will make the denominator 0? Well, the x value here that would make 5x squared 0 is x equals 0. So I know that x cannot equal 0. The other x value we would have an issue with is if x equals -2, because -2 plus 2 equals 0. So that would be -2 that cannot be plugged in for x. We've got all the values that would make the denominator 0, so now we're going to divide out. The x plus 2's divide out, and they equal 1. X over x squared, well, the x and one of the x's cancels out. X over x squared would leave you with 1x left in the denominator. So now what we have left is 8 times all of that is gone. That became 1. They all divided out. So that'd be 8 over 5x. Everything else is gone. So it's 8 over 5x, but x cannot be 0 or -2. If it is, we would get an undefined value there. Okay, so, and later on in math, you'll learn about the difference between what's undefined and indeterminate. But for right now, I'm just getting you used to rational expressions. Okay, last but not least, for a little more practice, let's factor out the greatest common factor. So 7 is the biggest number that goes into 7x and 49. So we get 7 times x. 7 times what gives me 49? 7. Beautiful. All over. Now we'll factor out the GCF in the bottom. Also 7. So we've got 7 times, that would have to be a 2x, because 7 times 2x is 14x, and then 7 times 3 would give us 21. Now what we have remaining to do, again, is figure out what would make our denominator 0. So that would be anything with an x set equal to 0. And I'm going to subtract 3 from both sides, and then divide by 2. And that gives me -3/2. So that's what x cannot equal, because that is what would make the denominator 0. Now we can go ahead and divide out. We notice we have common factors of 7. 7 divided by 7 is 1. And we're left with x minus 7 over 2x plus 3, but x cannot equal -3/2, meaning we could plug in any number we want into this. It will simplify down to that expression. You could use those numbers, but you cannot plug in -3/2. That's your restriction, your exclusion. That's it, peeps. Those are some of the simpler rational expressions. People sometimes have difficulty with them because they don't remember their exponent rules well. So again, bone up on those. Review those if you need to. Review factoring out greatest common factors if you need to. And always find those excluded values first before you divide them out. Because if you divide them out, you won't know what the denominator was that could make it 0. See you in the next video.